Okay, friends, so something came to me as I finished that last video you just watched. I mentioned the word probability a couple times in the previous video, and I realized we hadn't really defined what probability is or even means. I also used the word likelihood and chance, kind of carefree. I said them in the video like they were interchangeable, but yet I didn't really define what they were. So I decided, rather than telling you what they are, let's see what the world says probability is. Here's what Google told me. The extent to which something is probable, the likelihood of something happening or being the case. Okay, all right, likelihood. But the problem with that is we've used the word likelihood to describe another word, probability. And they've also put the word chance down here, expectation, all kinds of words that all mean the same thing. They're synonyms, but there's nothing in there that really tells me what it is. What is the probability? So I dug a little deeper, and actually a little bit later on in that definition was a mathematical definition of probability. Yay! The extent to which an event is likely to occur. Okay, that still doesn't tell me much. Measured, by the ratio of the favorable cases to the whole number of cases possible. Okay, this second part of this sentence, I think we can break that down and make it a little more understandable. Okay, so Google's mathematical definition of probability is actually pretty straightforward. They want you to form the ratio of what is called the event space to what's called the sample space. So the event space is just anything we're interested in an experiment. The sample space is everything that possibly could happen in the experiment. Looking to our Russian egg roulette example, we know that there were 12 total eggs in that carton. Of those, 4 are raw. So the ratio, or the chance, of getting a raw egg on the first pull is 4/12. It's really straightforward. As a matter of fact, that's one of the pros of this mathematical definition. It's simple, it's intuitive, it's also conclusive. There's no arguing that 4/12. There's 12 eggs, 4 of them are raw, 4 out of 12. The downsides to this mathematical definition is that you have to make the assumption that all outcomes are equally likely. And the reason why I put that second thing, it's a bit too nice, is these only exist if you can actually expressly delineate the sample space. Like if you can see that there are 12 total eggs in the case. Then you can say, oh, there's 12 total and there's 4 raw. Now, in Russian egg roulette, Jimmy Fallon tells us that. But when you try to apply this to outside sources, you might not be able to know exactly what that denominator is going to be, or the numerator for that matter. So we have to look to another definition of probability, one I call the statistical one. And this is my favorite. You go about it by running an experiment a large number of times. You then keep track of A, how many trials you ran the experiment for, and B, the ones you were interested in. How many times did what you were interested in actually happen? Form that ratio, and that's what we call your empirical probability. Empirical because it's based on data. So what we just saw was this. We watched 18 games of Russian egg roulette. 6 of those 18 had the first person drawing a raw egg. So we could approximate the chance of getting a raw egg is about 6/18. So you actually don't need to know anything about the potential outcomes. And that's one of the big pros of this method. You have to know nothing about how many outcomes there are or how many different outcomes there are. You may also have noticed this. 6/18 is the same mathematical fraction as 4/12. Now, if you go back to our video and watch it piece by piece, the 6/18 was only what the fraction was equal to after watching 18 trials. If we had stopped with just the Jimmy Fallon games, it was actually 6/17, because at that point you had seen 17 Jimmy Fallon games. And in 6 of the 17, the first person going got a raw egg. That means this probability is going to shift over time as you collect more and more data. And that is one of the, I call it a con, but I'm going to put cons in quotes, because I said you need lots of quality data to see the probabilities. That's not really a con, though, if you think about it. That just means you have to do good statistics and make sure you collect good data. The other downside is, I mentioned that this was 6/17. and then it became 6/18. 6/17 and 6/18 are very close in value. As a matter of fact, they're both within a margin of error of each other, as we talked about before. So I list those as cons, but they're not really cons. They're just something you have to be concerned about. Let's take a look at a statistical analysis of Russian egg roulette and see if we can see this 4/12. See if we can see this 4/12 after repeated trials. Let's take a look.